big ones for me, for architects, are locking your grid lines. Like, don't change your grid lines once you know the mass timber supplier is engaged. If you do go and change all that and you don't, we changed our grid lines, like, it just causes so many issues. The other one that's really helps out with mass timber is as well as a slab extent drawing, actually. My name is Kevin Rocchi. I'm Director of Engineering at Element5. My experience with mass timber began a long time ago when I was in my master's, studying at the University of Ottawa. And I studied plank decking and got involved with the professor Ghassan Dudek at the time, and just sort of flourished my love for timber in general. After I completed my master's, I went and worked for the Canadian Wood Council for 4.5 years or so. And there I was involved with codes and standards development, the software that the woodwork software that they work with, and as well as all their publications. And after a few years there, I decided I needed to get some practical engineering experience. So I joined a small engineering firm in Southwestern Ontario called Little Dice. Worked with them, just crunching numbers for a few years. We could figure out every single little math problem to be able to just solve any engineering problem that comes up. And then around that time was when Element5 was setting up their manufacturing plant in Southwestern Ontario. And that's where I grew up. And so I was super excited to be able to join as a structural engineer. And within a year, I became director of engineering. And ever since then, been expanding our team. We now have 16 engineers and architects who report to me. And we are more or less responsible for developing the drawings, completing the engineering, and working with our modeling team to deliver drawings for approval to clients. Once the drawings are reviewed and approved for fabrication, we then assist throughout the fabrication and construction process, acting as the engineer of record for the mass timber portion of the building.
Yeah, so it sounds like you've been with Element5 kind of like since the very early days. Like, if you had to give an estimate on like how many projects have run through you and your team, what would you say that number is?
So I joined when we were at project 30 or so, and now we're at project like we're getting into the 300s through 50, so at least 200 projects, something like that.
Right. So you and your team have looked at 200 plus projects, like just since you've been involved. And so there's a lot of experience and knowledge that you guys have seen and iterated on to get to where you are now. And that kind of leads us into like the main talking point for this conversation, which is like DfMA. Can you explain to me what that means and why it's so important when people are working with mass timber?
But what does DfMA stand for? And it's Design for Manufacturing and Assembly. To me, that is really like the whole process of delivering a piece of timber, whether that's CLT or glulam, to our production team. And there is a huge process to achieve that, which I can go through in a little more detail from start to finish, if that makes the most sense, Brady. So the process that we typically see is that we will be given a contract where someone is our engineer of record, has already designed all the members, but is not fully thought through connections. So they're at 100% DD, project's gone for tender, and we've been awarded the job for supply and engineering scope related to timber to timber, timber to steel, timber to concrete connection. So when that happens, we get involved. Or my team gets involved in that sense. And our first really thing that we need to do is the technical review of the drawing set. This is where I kind of describe it as like we really, for lack of a better word, we destroy the drawing set. We find all the mistakes. What have you not communicated in order, because we need everything. We need to know all the parts of our process, all the parts of the drawing, make sure there's no unknowns. And that's really what we're working towards is, hey, what are we missing? So we'll go through architectural, structural, mechanical if relevant, and we'll start looking for anything that is missing for us to be able to produce this product to the millimeter. So we typically have like a whole list of questions that we like to go after. So we always like to confirm, hey, have you sent us the latest drawing? Has there been a change since the tender occurred? We always request the latest Revit model, architectural, structural, because we really want those as a template for the new model that we'll be developing. And then we always need to ask about, hey, what's going on with MEP? What's the sleeving dates that you're expecting to communicate that to us? Do you have a BIM execution plan? And then at this stage, we also like to understand, is there going to be a construction sequence, or are we splitting the structure into multiple areas? If it's a big building or if it's multiple buildings. What is the actual sequence of those buildings and areas that maybe has been thought about so that we don't have to make it up from scratch? And then we know where are we focusing our structure and our drawings.
And why?
So, go ahead.
Sorry to interrupt really quick. If I'm an architect or an engineer and I'm hearing you say this, why is it important I understand it's important for you guys to nail all that down because you guys got to produce and cut all these pieces. Like, how does that make my life easier by nailing down all this stuff?
When you review the drawing, do you want to have a drawing that is clear and concise? Do you want to have a building that's aligned with exactly with what your expectations are? It's all about trying to make sure we're meeting those expectations and trying to find the right way to communicate the need for the answers to these questions is always a challenge. So, like I said, we do our technical review. We've got processes and with Blue Beam sessions. We've got typical questions that the engineers and architectural coordinators need to answer as part of that process that we go through checklists of questions. Some obviously not relevant, but of course we go through them all for every project. From there, we are developing an RFI. And that RFI is really the starting of, hey, do we have enough information to start working on this project? And we're often, depending on how many RFI questions, you pretty much have a good idea right then and there of the health of your project. If you're getting an RFI with upwards to 20 to 30 questions as your first one, maybe you guys have some, your project isn't as well developed as you thought. You've got a lot of unknown. If you're getting one with 10 or less, your project's in pretty good shape. So it's always a bit of a challenge to see what you get. And it's fun to go through the process. So obviously, like the next step would be we release that RFI, and you're essentially on that's when the client's on the clock. I like to think of production as a series of bottlenecks, and this is when the client is the bottleneck. The RFI response, hey, we need to know this so that we can produce this job. And so like response times, like I try to carry 10 days, but when it starts going beyond 10 days and the clients get upset about timelines, it's super frustrating for us because, hey, we didn't get the answers. They still wanted in that, and they still want us to deliver on time. But how can we deliver on time if we're not getting proper responses or timely responses from the third-party consultant? So if we get our response, we take a look at it. Let's say 10 days later, we get our RFI response. We have to ask ourselves, is there enough to start engineering? Maybe we can start engineering before. It kind of depends on how many RFI questions, of course. If not, we're going back to the start of the RFI process. Another RFI, same questions. Maybe you ask differently. Maybe we need clarifications, whatever it is. So once we've got enough of our answers and we can start engineering, we put whatever tool we need, spreadsheets, software. Typically, we're using Woodwork Sizer for sizing members, and we're using RFIs for modeling the structures, for like finite element modeling them anyways. And then completing all the engineering tasks, developing details, looking at trying to find all those unique conditions and so on.
And what are some of the things, like the common troubles or challenges that you generally see come in, like through this RFI process, that's like, this happens time and time again, that like maybe architects and engineers might not be aware of? Maybe they're newer into the mass timber journey and they haven't gone through it a bunch of times, that would help them like speed this process up.
The big ones for me, for architects, are locking your grid lines. Like, don't change your grid lines once you know the mass timber supplier is engaged. If you do go and change all that and you don't, hey, we changed our grid lines, like, it just causes so many issues. The other one that's really helps out with mass timber is a slab extent drawing, actually. It's often done for concrete buildings, where the architect will create a slab extent drawing, and the same thing applies for mass timber. It really helps expedite where are you expecting to have timber on this project. And if there's a section that's cut and it doesn't quite show the extent, but there's an overhang from a grid line, well, we're going to be asking you what's that dimension, because we can't trust what's on the page or on your detail. You need to confirm it. So slab extent drawings for sure. From an engineer's perspective, the questions that are often asked are like, hey, like obviously you need to communicate what are the design loads, and everyone has a different way of doing that. But the challenge is that if you report a factored design load, it says 10 kips, and it's just, but like when I see 10 kips, I say, well, what load level is that? And specific for mass timber, so for mass timber is your dead load higher than your live load? Because from a strength calculation perspective, we have load duration factors. If we don't know that the dead load is 2 times higher than the live load, well, then when I'm doing my connection design, I'm not going to know what CD factor to apply. It's in US, KD in Canada. But that load duration factor is super critical. So often we're looking for the engineers to actually give the dead and live load, and whether it's seismic wind, as separate loads. And we can go and factor them ourselves as needed for the purpose of our design. And both of those, like those two critical things, are essentially the first questions on a job. Similar things go for the diaphragm design. For engineers, the loads, showing your diagram. Like we look at the building and we think, okay, like where is their lateral load path? We're not like, we're trying to interpret what you've done, because we need to be able to design our diaphragm connections. If you're not providing a diagram showing, hey, these are my shear diagrams, these are my load levels, this is where my shear resisting elements are, it's very challenging to sort of reverse engineer your job for you. And the more information on design loads is the better. And splitting it up makes it so much simpler, and everyone's on this same page, and there's transparency between us all on the connections that we're reporting. If I run into situations where I don't get those answers, what I often resort to doing is reporting the load level. What is the capacity of a connection? And trying to ask the EOR, like, hey, you didn't want to give me this, so you better review and approve that this is the capacity, this is my load duration factor. Does it work for the loads you intended?
Got it. I want to circle back really quick to the grid. So I've heard different members of different projects teams talking about trying to keep the grid agnostic until you dial in exactly who you're going to use for your supplier. So everybody's got different panel sizes, capacities, characteristics, etc. How does let's say an architect or an engineer make sure that they're optimizing their design and their grid to like make the best use and get the most cost effectiveness out of, say, like Element5's panels?
So from a width's perspective, of let's do it in 2 questions in this one. I'm going to split up for first CLT. So CLT, define your top of slab. Really, like that's really what's key for the elevations. Extents, I don't think that's as much of an issue for CLT because, well, it's going to be dependent on, obviously, like we want a slab extent drawing because that'd be fantastic. But I will say for CLT, what engineers and architects don't realize is that there are those panels in North America with those thinner lamellas, the 17 mil lamellas. So you can get like instead of it being like 3, like I'm going to use metric in this case. Okay. So 3 35 millimeter thick lamellas to make a 105. Well, then the next size up is 5 lamellas and you get a 175 millimeter panel. But sometimes I like to throw in thinner lamellas into the cross layers. Like those thinner lamellas, like Element5, we're not vertically integrated with a mill, and procuring those lamellas is really difficult. No one wants to make anything in North America except a 2x6 or a 2x4. It's 38 millimeters thick. When you want a thinner lamella, we're resorting to buying high grade material that's maybe an inch thick and then planing it down. It's a waste of material. You're not actually gaining much. So if you're gonna specify CLT in your job, and you're like, oh, I can reduce the panel thickness from 175 to 139 and save on the weight, it's literally not worth it. It's gonna be the same price for us to sell you a 175 as it is for a 139. And in fact, your 139 panel is wasteful in terms of fiber. You're sending fiber to, in our case, if we're sanding it down, we're sending it to feedstock, all the sand, all the sawdust that comes off the lumber. So it just depends. But so for those ones, yeah, like CLT, I think that covers it. But for Glulam, you're right. It's like, what are the extents? Every Glulam manufacturer is doing things a little bit differently right now, in my mind. Everyone's got their own standard width. Depths are different. And we'll get into this hopefully a little more later, Brady. But like the ultimately, you probably want to center line your beams and your column. Rely on it being center lined, and then knowing, hey, like this beam width might vary half an inch, and just sort of understand that might be the case as you go through the process. And same with your depths. That would be my suggestion, especially in the DD phase when you don't have a supplier locked in.
All right. Okay. So we've gone through the whole, like the project's been awarded. You've gone through your RFI. You got all the information that you needed. Where does that process pick up next?
So at Element5, what we do is we need to model that building in 3D. And we do that using SolidWorks. This is a little different than a lot of the other manufacturers in North America. And we've set our process up to do it that way. And it works. And it's not really, may not work for designers or myself as the engineer who was trying to make a drawing to communicate what's there. But man, does it make the process of creating fab drawings and having production using them to create models and drawings, models and single piece drawings, everything. So it's like we think more about, hey, we want this process easy for production, not so much for engineering, which is okay. We've learned to adapt. So we model it in SolidWorks to the millimeter. We've got all our questions answered from our RFIs on extents. We've got the grid lines locked in. We know our member sizes that we want to supply. Those are going into an RFI for sure. Hey, you put this size, this is the actual size. Like that's the very first RFI, right? Confirmation of Glulam grades and CLT grades, thicknesses, width, steps, everything. So model it, and then we're really working towards a issue for approval drawing. That's what we call it. And we're working towards asking the questions. Like, again, we need that sequence. If we don't have it, we need to know if you're going to get MEP to us at all before then, because we can't be spending, like everyone has a different way of doing MEP. The best way to communicate it is actually like a 2D drawing, saying, hey, this is where your MEP is, and it's got to have references to grid lines. These grid lines that we've locked in already, of course. And if that's communicated, it's easy to implement into a model for fabrication, because it's like, hey, this is all defined, and we need to make sure we're filling all the gaps in the engineering, connections, whatever else. So we're getting all our details compiled in Revit. We then take our SolidWorks model, convert it into Rhino. Then from the Rhino file, we can bring it into Revit. And from there, we are making a drawing of the building in Revit for approval and trying to communicate to the client, this is what you're going to get. This is everything thought out. These are all our connections. Please review. And we're really looking for, hey, you've done it. This is exactly what I wanted. I've got approval. And that's the sort of process. And of course, you could go approved as noted, revise, resubmit, and you keep going back around the circle until you get all your answers to be able to produce this building.
Got it. And for the sake of simplicity, you got the thumbs up maybe on the first round or very shortly thereafter. Now I imagine you're moving into like planning for fab and production, right? Because everything's dialed in, everything's ready to go. It's approved by the clients. Now you guys are lining up like production slots and getting it into your queue. So I imagine I see a note in there, but like your sequencing of like what's going up when, where, and in what order, like having that nailed down, I imagine is pretty important to like what you guys are fabbing when and where, right?
Yeah. So when we first started like really producing CLT in North America, like 3 years ago, more or less, when I started at the department, we were really set on like, hey, like get your production slot when you've got your approved drawing. And we were really focused on one building at a time, one project at a time. That like it was only one project in production, but we've gotten better, right? We have processes now where we are tracking the jobs that are supposed to be coming in. If we can know their sequence, we know their timeline, roughly 20 picks a day, let's say, we can build out the schedules and level load our production so that we are doing 3 to 4 jobs at once. And that means that we are less time putting things in inventory or in storage if we produce too early and they delay their job for whatever reason. But it also allows us to hit timelines better. And we've been slowly becoming more and more sophisticated. We're getting better. We're always getting better, right? The whole industry is getting better at delivering these types of buildings. So we have a good idea of where your slot's going to be when you're in design. We know we've built out a schedule. We've level loaded it. We think you're here. We know the volume that needs to go through the production, and we can put you in the right spot and get pretty accurate. And then if we're hitting our deliverables for engineering, then the rest of the deliverables are very easy. But even after you get that approved drawing, there's still a process of, hey, sure, you've got a model approved. You've got connections approved. But you still need to model every single piece to the millimeter. Build in those tolerances. Make sure they're all there for your connection detail. Get the custom steel put together. Start with your bill of materials for fasteners. All that stuff needs to come together to be able to actually deliver the job to production. We now do from an engineering perspective, we're doing our takeoffs on fasteners right when we release the first IFA drawing, because we need to have that information as quickly as possible to our procurement team so that they can start, hey, fastener supplier, please make sure we've got this allocated to us, right? And then same with the steel, like custom steel is, every job has a little bit of custom steel usually, not very few that do not. And you got to make sure that they are our steel fabrication partners. We don't do it in-house, that they're like, hey, these ones are coming along. And then they need the time to fab and so on. So there's a bit of a steps there to, hey, model's approved, but we still need to do the internal model approval, make sure we're satisfied that everything's modeled correctly. Tons of review single piece pad drawings for the custom steel, single pieces of CLT and Glulam, get it all released, get the fastener takeoffs done and released, and get it all together so that we can deliver those trucks And you're kind of focusing on almost like by the truckload. You want to have like, if it's going to be like, okay, like we know that there is like 7 panels that fit on this truck. Well, those 7 panels are going to be batched together. And we need to know, are they going to be in the right order? Are you going to offload them quickly? So you just want to stack them in reverse order so that by the time the one you want to put on first into your structure is actually in the bottom. And knowing all those questions and coordinating it with the general contractor and installer are all super key to the process and understanding it all.
Yeah, so it's like, it's way beyond like, do we have the design and the drawings, right? It's like literally like, how are we stacking the trucks to make the job site execution go seamlessly? So it kind of sounds like communication, and prompt communication is what helps speed and smooth things along. Because like you said, like if you're extending past your 10-day RFI window, it's like, okay, well, that's going to slow literally everything down the chain, right? But it's like, hey, if I can get very quick responses like, hey, are you picking panels off the truck and installing them right away, or are you just unloading them because that's going to affect the order that we stack it in? Like a quick email back and saying, this is what we're doing will help streamline a lot of stuff. So it's like, does it come down to communication?
Preaching to the choir, Brady.
Oh, yeah. I'm asking questions because I don't work on the job site, and I'm trying to understand all this because, like, you know, like, let's rewind my journey into mass timber 2-3 years, and you know, I originally got into this as like a developer trying to like put panels in a smaller project, right? And so like my assumption was like, okay, we're gonna use mass timber. It's like, okay, well, they're just shipping a bunch of blank billets. I didn't know the word billet, right? But they're just shipping a bunch of panels. Like the order that they went on the trucks, like where's this connection getting modeled in here? It's like, if I'm used to doing things like stick frame, it's like, well, the 2x4 bundle shows up and they frame it, right? Or what have you. So it's like, there's a lot more that goes into like when you're working with a factory that's producing an entire large scale building like this.
Yeah. You know, like you just said though is super key because like that what you were trying to do 3 years ago, Brady, is like what the whole industry is missing. I can make you a billet. Billets, that's not the bottleneck. Bottleneck is being able to make the model yourself, knowing what you're going to cut, getting that into a CNC and cutting it. We need people like that you just described, like what we call industry innovators, people who are willing to buy a billet and do a value add. That's really what's going to spark more production for the entire industry. We need people willing to just like, we can produce you a billet, have someone do the CNC themselves, cut it themselves, do some additional steps to create a job. And that's what we like, I feel like is missing right now and we need more of. And so I hope that although you became a podcaster, let's say, I hope that marketing, like I hope that like there's other people who are like, hey, like I'll start a small business. I'll make cabins. I'll make shed, whatever. It doesn't matter. Something extra, some sort of additional innovator step is what's really missing right now in the entire industry, as far as I'm concerned.
Yeah, I won't put my foot in my mouth, but you know, maybe something in Nick and I's back pocket might be something along those lines later down the road. But I've talked to a lot of companies that are like charging headfirst right into that gap that you're talking about. It's like, hey, we just want to buy X number of blank billets a quarter or whatever. It's like, that's it. We just want to buy these billets because we're going to do all that, the modeling, the fab, and everything else from that point. So I think we'll see that definitely in the next. Well, I know that there's multiple different operations getting set up in the next year, right? But they have plans to do like dozens and dozens every year, and that's just one company. So hopefully we'll see a little bit more on that line of thing. But I digress. Okay, so we've got the panels on the truck. They're out to the job site. Like, what else do project teams need to know to make this whole mass timber thing successful?
I think understanding definitely like the sequence and everything. Like, hopefully you've already got that all planned out, right? Hopefully by the time you're getting it, you are ready to go. But the question that's always coming up is moisture management on site. there's tons of initiatives right now in the industry to sort of give better guidance on moisture management on site. The big things, the big takeaways that I always try to reinforce, because like I'm not going to be there. All I can tell you, I can only give you advice, because I'm not going to site to tell you how to manage moisture. I've got a moisture management plan that I share with the general contractors and installers, but really it's them. They're the ones who need to manage the moisture on site. So one thing that we've definitely been going away from is away from plywood splines. Plywood splines, like you get the rain in them and the moisture doesn't get out. You have to replace them during construction. It's just not worth it anymore, from my perspective. And so we've been going more after like a steel strap, such as Simpson's LDSS with fasteners and butt joints, and it's quite competitive with a plywood spline and the things like that. Like, okay, we know that if we do that, then at least like we're not going to have the plywood issue. Then it's like, oh, well, what else can we do? Well, taping the joints, absolutely. That's always a good one. There's always the value add where you put on a product like Slope Shield, and before it even leaves the factory, that will help protect the panels during construction. So, and then the thing that I've learned from the experiences we've had on site where we have had moisture issues, which isn't very often. Luckily, like Element5, we edge glue our panels or our layups or our single piece laminations as we make our panels. So I find that there's no gap for water to sit in most of the time, like especially during construction, during that phase before the panels really dried out. So don't have a ton of moisture management issues. But the things I've learned are that, hey, like if there's standing water, snow, get rid of it. Like that's got to be the highest priority. But that's no different than a concrete or steel building. Get rid of the standing water. It's just this rule of thumb. Get it off. And the panel's going to get wet. But if you have an open structure, and it dries fairly quickly. And I've experienced that myself, where we did a project last summer where we had balloon frame walls on 2 sides of the building and 3 stories up into the 6-story building. And top 3, they were in construction on the 6th level at the time. And I went to site. They already had the balloon frame walls up on 3 floors. And of course, rained like heck. And there was some moisture inside the building, and you could feel the relative humidity inside those bottom 3 floors. It was high. It was wet. But the second you got up to that above that 3rd floor that was open, hey, it dried right out. The wind, like just allowing for wind to blow through the building. Like any panels that it got rained on those top 3 floors, they dried right out during that phase of construction and didn't have issues. So getting rid of the standing water, trying to keep it open as long as you can. These are like just basic things that allow the buildings to really deal with that moisture issue that could potentially happen. Because I did light framing though, I am of the opinion that get it built as quick as you can and put the roof on.
Yeah.
So I always advocate for that as well.
Yeah. Yeah. It's like a balance of both approaches, right?
Yeah.
All right. So we kind of like went through the DfMA. What is it? Why is it important? How does it make the project successful holistically? What specifically about Element5 are you guys doing right now to kind of like advance this mass timber stuff? I know you guys are going through like a big expansion, but like, what does that actually mean?
So, in the last 2 years, we've been sort of we've received an investment from Hochschlager, Nordic Timber, who is part of their sort of so they've recently become majority stakeholder at E5, and as part of that them becoming majority stakeholder, they have invested a new glulam production line to our facility at E5. So we've been going through this massive expansion to put in this new glulam line, but we've been really bringing in all this amazing technology. My boss likes to say it's the most advanced glulam line in North America, but really it's a production line that already exists at the main Hochschlager facility in Europe, and we've copied it and put it here. And we're going to be able to make 50,000 meters cube of glulam with this facility. So when it's fully operational. So we're getting really excited about glulam now. Like, we've been doing CLT for the last few years, and we had the line was either you went to CLT production or you went to glulam production. And we now, so we were kind of limited, so we always split. And now we've essentially said, nope, this will just be our current line is just for CLT production, and we won't use our glulam press at all. We're going to have a whole new glulam line. So what we've done is we started expanding the building. The first thing we're doing is we knew we needed to do is we added additional area for CNC and value add. So we knew we needed more area to be able to do what we needed to do. And actually, those changes were implemented like last year. It had like crazy repercussions on our ability to CNC panel. We moved all our CNC machines in such a way to allow for continuous flow. So you now have panels coming off the production line and getting into line to be CNC'd. Historically, CNC has always been our huge bottleneck. Like, to pick up a panel, CNC it, remove those pieces, it was all done with a crane. We now have it on conveyors, and we make stacks of lumber for the 3 CNC machines and we have conveyors at the front end of them and the back end of them, so that when you are producing a panel, you already have another one ready to go. And then the second you're done producing it or cutting it up, you've got it pushed aside and moving the next one in. And it actually moved our bottleneck back to production, which was really nice to see. Like, in a production facility, the bottleneck's going to change constantly, and it does. It changes from production of panels, CNC, to shipping. It's kind of like a dance that you play, and trying to put enough resources to balance all 3 to keep the flow as quickly as you can. So the first thing we did, expansion of this area, and it's already happening, and it's great. The other thing we did is that we've added a sorting and grading building. So in the past, what we had was a group of about 10 to 15 employees who would essentially take stacks of lumber, just 2x6, 14 footers, and do a visual inspection and put them on kiln sticks for the purpose of getting them from 19% moisture content down to 12, so that we can fabricate CLT or glulam with them. And those 15 employees now all work on a sorting line. And sorting line has this machine called a Microtech GoldenEye. And this Microtech GoldenEye, yeah, I know, it's a cool name, right? Of course, it's the original movie. But essentially what this machine is doing is it's checking the moisture content. It's checking the MOE of every board, dimensional sizes, lengths, width, and it's doing it all like an extremely fast speed. And from that information, it can tell you, hey, this board is wet. Okay, it needs to go to the kiln. So now it's going to a different bucket. But it also can sort for higher strength lumber. So it can say, hey, this piece is a visual B, let's say, in following CSA, 0122 terms, or a 302-20 if you're following visual requirements for ANSI, let's say. And it can tell you, oh, this board meets this requirement, and puts it in a category and sorts it. So now we're sorting our lumber like way more efficiently than we ever could before, because the machine is doing it for you. The other cool thing that it can do is that it can mark up. It can take take the X-ray of the piece of wood and know, oh, there's a defect here that's bringing it down from 302-20 to a lower grade board. Cut that section out, and then that board now is a 302-20. So it's just so sophisticated and so awesome to see, and I'm so excited because it's just like we're sorting lumber like never before.
What does that translate to, like the benefit to like a client?
It means that, like, so the reality is that visually graded lumber we have this like terrible, like, we are so dependent on visually graded lumber in North America. And in my honest opinion of visually graded lumber is that it has to go. It is an outdated method of sorting lumber, right? All we're doing is we are looking at the characteristics of decay, and sort of someone's taking it and saying, oh, it's number 1, it's number 2, whatever it is, flex structural. And we're not actually utilizing the properties of that board or the forest by just doing visually graded lumber. You're throwing everything from the basket into a big, larger group. And this actually essentially allows you to, this new machine, the Microtech GoldenEye, is essentially saying, you know what, we're going to make MSR essentially out of everything. We know the stiffness of every board. So now you're going to have a higher strength product and one that has less, like if you're just, it allows you to use the breadbasket even better than we ever have before. And my general opinion is that like the whole industry, not just mass timber, needs to actually migrate towards MSR being the standard. That would align us with Europe, who use strength classes. It's very similar. We have our strength classes. It's MSR. And how to get there, I don't know, because we're so dependent on visually graded lumber. But there's definitely steps being taken in Canada to get us there. And we'll see what happens. Hopefully the US market will also jump on.
So let me ask a clarifying question to make sure I understand this right. So you're basically taking your feedstock and you're running it through this machine, and because it's using the technology to grade, evaluate, tell you what steps to take, at the end of that, you basically get the MSR equivalent with the lumber, which then means you can rely on those different values to create stronger panels or glulam, etc.
You got it.
And so, are we there yet, or is that coming to where, like, hey, now you can rely on those values into the panels to maybe do things in a more cost-effective way or a better way than you couldn't do before? Is that where we're getting at?
That's where I'm going. Yeah.
Okay.
So, like, I don't know if it's really necessary for CLT, right? CLT, like, it works for, like, you don't need a high strength panel all the time. You do on occasion for sure. But the reality is that CLT really started in Europe because they were trying to find a use for that lower grade material. They wanted to find a home for the pieces of wood that were not as strong. And then you dedicate that high strength material to glulam, where you need the high bending strength, you need the high stiffness. And how we do that is completely is something I want to get into as well as we continue it. So right now, let me so, like, on top of the glulam line, one thing that we're doing right now, and I'm working with a number of industry partners up here in Canada, Western Arch Rib, Goodfellow, RMSIF, Mercer, Mass Timber. Hope I didn't forget one. Yeah, either way, we are working right now. If the CSA 0122 is the glulam design standard in Canada, and what the glulam design standard in Canada did was when we did the last code cycle, which finished up earlier this year, and we published the new version, is we preemptively added new layups that are untested. And what we did with this layup is that we created a new type of lam stock. And this lam stock is called a remanufactured lamella. So what you do is you make let's say we take a glulam beam that consists of that visual B board, the 302-20. We know its stiffness. We know its visual characteristics. We make a homogeneous beam, and then we rip that beam along its height into laminations, rotate them 90 degrees, and then put them in the bottom of a glulam beam. This is called a remanufactured lamella. And when you do this, it actually distributes your defects. So now your finger joint, and like typically the bottom lam of a glulam beam will drive the bending strength. So now what we're doing is, okay, that bottom lam, you're going to have your defects are now staggered. Your finger joints in the bottom lam are now staggered. So you can get a higher bending strength. So right now, we've already set up the CSA 0122 to have these remanufactured Glulam grades in there. And we are working towards fabricating these beams and having them tested at the University of British Columbia. And then we will essentially have design values in CSA 06. And that same information and testing that's being done here will trickle into new grades that can be supplied to the US market as well.
Interesting. And do you just glue it up like you normally would? Can like you glue edge grain to face grain?
Edge grain to face grain. So yes and no. So let's talk about that too, because like there's a few parts of this that I want to be clear about. So like there's new grades in 0122, working on those with all the industry partners. But I'm also like we're working on the National Research or the National Resources Canada is provided some funding for this work through an IFIT. That's what they call it. And we're doing like total characterization of the lam stock that is used to fabricate Glulam in Canada. We are doing like 1200 tension tests. Weak axis bending is another area that we're looking at. We're doing 480 weak axis bending tests to establish what to do. Right now in Canada, we are in 086, we are overly conservative, assuming that it's just a number 1, number 2 in the weak axis, no matter the material. And we know that's wrong, and we know we're undervaluing the weak axis bending, so we're working to fix that. We've got all sorts of grades that some of the design values don't make sense because they were never tested. So we're working to get some of those grades tested. I've got a good feeling that Glulam shear is undervalued in Canada, and we can get better design values. So we're doing some testing there. There's some new Glulam grade for columns that we're adding that'll deal with like lower strength material. So working on a whole bunch of stuff there. But then, like, what do you do when you want to manufacture a beam that's wider than, say, 175 mils, right? You're getting into this edge glue versus space bond. So the reality right now is that when the standard sizes that are followed are often based on, hey, 2x4, 2x6, 2x7, 2x8, 2x10, 2x12. When we had lam stock are commonly made for that, right? And we're kind of out of date. Like that was what the reality was in 1970, 1980 for Glulam and the widths. But that's not what's available now. There's no 2x12s available to make a 300 wide millimeter Glulam beam that's needed. And so one of the challenges one of the things we did to 0122 as well was actually we reduced some of the widths of our Glulam beams so that when you're doing, say, what's commonly done is you do the brick lay, where you put two 2x material together, say a 2x6 and a 2x8 to get a wider member. And then you stagger it all the way up and down. The challenge with this is that if you don't edge glue, you can end up with gaps. And this process for manufacturing is slow. So one issue we had was that people will often specify, say, 265 millimeters, because that's what the CSA 0122 and 086 tell you to do, because that's the standard width. But the reality is that we want that width to be 5 millimeters less, because the material needed to make that 260 wide otherwise ends up with a gap. So we're working on cleaning that up. But the reality at E5 is that this new production line will not be doing bricklaying in the immediate future. What we're going to be doing is we will be going with, like I described, a homogeneous lam stock. So we're going to if we want to make a beam that's 280 mils wide, well, we're going to make a homogeneous beam that's 280 mils wide. We're going to take a lam, that P20, like the high strength remanufactured lam stock that I described, rotate it 90 degrees and glue it up to make a 280 wide by up to 1.3 meters high beam. And that will work, but again, it's only 280 mils wide. It's about 11 inches. What about when you want to go wider? Well, that's when you get into what's called block gluing. And there's this huge challenge right now with block gluing because the 0122, 0177 in Canada, as well as the US standard, only have one approved glue to do this. And it has formaldehyde in it. It takes 6 hours to dry and is really a bit, and it has to be what's called a gap filling adhesive. And this gap filling adhesive is the only one that ANSI will approve. And I know for a fact that Europeans are bringing in glulam that will not meet the standard. Any member that you're likely getting that's beyond 280 mils wide from Europe isn't actually going to meet ANSI or CSA because it will have been block glued, and that bond line to the block glue will not meet the requirements for fire for this product. So there's a gap right now. I'm sure the glues are good and they probably behave fine. But our standards in North America are limiting us from and forcing us to use this one adhesive. So I'm going to be working with the various players to try to fix this, but it is one of the challenges I'm currently facing. To make anything that's wider than 280, we have to let it dry for 6 hours with this massive with this glue. That's a gap adhesive.
So with the innovations in Glulam that you're working on that are coming, etc. Again, tying this back to the project teams that are listening, does that mean that they can do different floor-to-floor heights? They can get better performing Glulam, higher strength, longer spans? Like what does that translate for them?
Absolutely. Like the reality is that right now, spruce pine from Canada and even from Western spruce pine, or even like as they call it I believe that's what the grade is. Either way, if you made it from spruce pine fir from Canada or spruce pine fir from the US, you have historically never gotten better than a 2000 psi allowable bending strength. The way we're sorting it, the way we're doing this strength, like you will for the first time be able to get a spruce pine product that gets better than 2400. I'm expecting it to be even higher. Whether or not we go after it, I don't know yet, because the need on the market in North America is a 24F 1.80. Everyone wants that grade of glulam. And so like that's what we're trying to achieve. And I'm sure we will with the spruce pine. So yes, like the spruce pine will be essentially same bending strength and stiffness of the Douglas fir on the West Coast.
Got it. And so does that translate into cost savings?
Essentially the volume will be the same. Like we won't need to change it at all. Like, so there will be efficiencies that'll come. How long those efficiencies take to trickle through the industry? Maybe give me like 086, 29 is what I'm targeting for these new glulam grades. If I can get them into the one published in 4 years from now, let's say,
okay,
I'm pretty happy with my progress, and it'll be a little easier to get them into ANSI. It won't get them into ANSI, but it'll be easier to get design values for APA for those grades.
Yeah.
Who I use for our third-party certifications.
Well, you're a busy man, like going through hundreds and hundreds of projects, as well as developing the future Glulam with some partners. What's next for you? Is there anything left to fill your schedule with, or are you already topped out?
I'm topped out. I'm grateful for my team, like that we've been working through for years. Like they really are doing the project work now. I'm just hey, do you need help when you need help? They are the ones running the project work. I'm busy with this development conversations that we're having. So yeah, like what I just described, these new Glulam grades, like that's really what I'm excited about right now. Trying to get this new Glulam technology or grades into codes and standards is a goal. What I'd really like to see is maybe we could get a unified standard for Glulam. Because right now there's one North American standard for CLT. It just makes everything so simple for delivering mass timber projects. But you don't have an equivalent for Glulam, obviously, because they've been around for 30, 40, like ever since like 1970s, let's say. So it'd be really nice to maybe work with industry players to innovate the industry to have a North American standard again, but for Glulam.
Yeah, for sure. So, well, if somebody wanted to learn more about what you guys are doing, work with your team, who do they reach out to and connect with?
So because of where I am in our process, I would suggest that you always reach out to one of our sales people, specifically Lee Scott would be ideal. You can find him on LinkedIn. I'm not a big social media guy, so I try to keep a little profile, but for sure.
You shuck all the messages off to Lee, then I'm sure he's happy to pick them up.
Yeah.
That makes sense. We'll link Lee's info down below, and then if anybody's going out to Denver, Lee will be down there for the Mass Timber Group, so you can connect with him in person. I guess we got time for one last question. And so if you had let's say a team of architects and engineers, and you're standing up in front of them, what's one thing that you would leave them with to make sure that their mass timber projects are like mass timber ready in this DfMA conversation?
Collaborate early. Do a design assist. That, like, we didn't really touch on that at all, Brady, but like design assists are really helpful to getting your job on track. We will help you early on in the process of saying, what are you missing? What are you still needing to do? So that by the time you go for tender, and if you listen to everything we suggest, by the time you go for tender, there won't be any surprises. Your clients will stay happy. So I'd suggest you engage early if you're unfamiliar with mass timber. If you are familiar, hopefully take the advice we already talked about slab extents and grid lines and everything else.
Yeah, makes a ton of sense. Well, thanks for talking with me, Kevin. I appreciate the conversation. I'm excited to watch what you guys are doing. And then Nick and I will be sure to come out and check out your new factory here in a couple months and see it in action.
For sure, Brady. It's been a pleasure.